Here's a decay problem. Again, I have to remember that but either one of these two formulas is always going to be assuming that I'm dealing with the amount I have remaining, the amount that's present. So an unknown substance decays at a rate of 10% every 3 days. What is the half-life of this substance? So again, if I'm losing 10%, I'm going to have 90% left. These formulas deal with amount present. So when I deal with, figuring out what P is with respect to P sub 0, when I'm looking for A, the final amount is going to be 90% or zero point 0.9 times P sub 0. And that's going to equal P sub 0, A to the third power, which means A to the third power is zero point 0.9, which means A is going to be the cube root of that, which is about equal to 0.9655. Now, again, here's an A value that is less than 1. That does tell me that I do have a decay. So my formula is going to be that P sub 0 equals, or P equals P sub 0 times 0.9655 to the T power. Again, I'm only writing 4 decimal places, but I will be, anywhere I have that 0.9655 being used, I'm going to be using all the values that are stored on the calculator, and I've stored it in the memory by this point, as far as my calculations go. So again, if there's any discrepancy between what I get and what you get if you're working this out yourself, it's probably because you're using just the 4 decimal places. I'm writing 4 of them, but I'm using all the ones that my calculator had stored when I did that cube root of zero point 0.9. So we want to know what the half-life is. So again, a half-life is the amount of time. So we're looking for time, T, when I have half the original amount left. So my final amount, P, is going to be 1/2 the original amount. Excuse me. I divide both sides by P sub 0. I end up with 0.9655 to the T power equals 1/2. I can natural log both sides, which would allow me to bring the T in front as a multiplication on the left. As I said, I've also could have easily just said I'm going to do the, log base 0.9655 of 1/2 and then use the change of base formula in order to accomplish the rest of it. In either case, I would end up with a situation where I had the natural log of 1/2 over the natural log of 0.9655, which is about 19.74 days. When I'm using the other formula, again, I'm going to find K first. Still same setup. I'm using the fact that 10% is decaying every 3 days, so 90% will be left after 3 days. The P sub zeros would cancel, leaving me e to the 3k equals 0.9. I would take the natural log of both sides and then divide by 3. And that k is equal to about negative 0.03512. Now again, when you look at this, k here, is negative, and for this kind of setup, a negative k value indicates a decay. So I should expect to see consistencies as I go along. If I end up with a positive here, I'm not doing something right. I need to go back and fix it. So now the formula is going to be this, and I'm going to do the exact same thing I did with the other formula. I mean, my final amount is going to be 1/2 the previous amount. Divide both sides by P sub 0. Natural log both sides. And divide by that negative 0.03512. So forth and so on. Again, I'm using all the values that are stored in my calculator, whereas I'm only writing a number of them that here just for the sake of, just being clear about approximately what I'm getting so that you could follow along. And if I do that, I get about 19.74 days. So again, I don't, in this instances where I'm doing growth and decay, as long as it's not money and compound interest, I don't care which one of these two methods you use. If you use either one correctly, you'll get the same answer regardless. If you're dealing with money and they're talking about compound interest, and usually you're going to see the word compound as being part of it, you know, you have to use one of the appropriate compound interest formula. Whether it's compounded continuously, you're going to use the PERT one, PERT one. And if it's anything else, any other type of compounding, you're going to use the A parenthesis 1 plus R over N to the NT power thing. So for regular growth decay, you have a choice of 2, whereas with dealing with money and compound interest, you have to choose one or the other based off of the type of situation you got. So keep that in mind. It isn't like you have the same kind of choice when you deal with money. You know, when you deal with money, it's going to be one or the other based off of how you're compounding. Whereas this one here, it's your choice of one or the other based on which one you prefer to do.